Hi YouTube, Timothy Unkert here. In this video, I want to discuss arithmetic and math in the Dart programming language. So in my previous videos, I've used dartpad.dev. In this video, I'm going to use a local development environment. I'm using the Pulsar text editor. I have a file open called arithmetic-math.dart. And I'm going to be running the Dart programs via the terminal. So this will give you a little different perspective on how you'd run Dart programs on your local machine. All right, so let's start off with some basic arithmetic. And I'm going to create my main function, so I'll do void main. Make this a little bit larger for you. And let's just print. We'll do 10 plus 3. And let's duplicate this a bunch of times here. And we'll do subtraction, multiplication, division, and then we're going to do this percent sign. I'll explain that in a moment. So I'm going to run through each of these calculations via the terminal. So I'm going to pull up my terminal here, and to run this program I'll do Dart, and I'll start to type the name of the program and hit tab to autocomplete it. And we'll hit enter, and we see the program runs. We have 13, 7, 30, 3.3 repeating, and there's a 5 on the end here, and that's due to a slight loss of accuracy. And then we have a 1. So when we do 10% 3, that's the modulo operator, that gives you the remainder of the division of 10 and 3. Okay, I like to always check out division on a programming language, because sometimes when you do 10 divided by 3, in certain languages like C, for instance, you'll get 3 back because you do integer division. This does floating point division in Dart, so that's good to know as you move forward. Okay, so those are some basic math operations in the Dart programming language. Let's now look at some more advanced ones. So in certain programming languages, let me duplicate this, you can do 2 asterisks and get 10 raised to the 3rd power. Now if I save this and I go back to my terminal and run it, I'm going to get an error. And you see I get an error here. We can't raise a number to a power with that method. So we have to import what we call a math library, which is a little bit of extra code that will allow us to do some extra things with Dart. So to do that, I'm going to type import, and then between quotes, I'll do Dart :math, and just end that line with a semicolon. Okay, so now if I want to raise a number to a power, what I can do is I can do print, and I can do pow, and then I can do 10, 3. Okay, so it gives me this additional function I can use where I can pass in the 2 arguments, 10, the base of 10 and the power of 3, and I can get back the result, which should be 1,000. So let's clear this out and rerun this, and we get 1,000 as expected. Okay, so that's one of the things we can do. With the Dart math library, we can also print out some important math constants. So let's print, for instance, the value of pi. We can do that. We can print the square root of 2, just like that. And we can print Euler's constant, E, which is a very important number in mathematics, just like that. So let's run this to demonstrate. Okay, so we go ahead. We get 3.14, etc. That's pi. We get 1.414, etc. That's the square root of 2, and we get 2.718, etc. That is E, Euler's number. Okay. We can also do some other functions with this math library. So what we could do is we could do a max function, which will give us the max of 2 numbers. We can do a min function, which will give us the minimum of 2 numbers. And we can do sine, cosine, and tangent. So we'll do sine. Let's do pi halves. Typically these are in radians, so that's why I'm using pi here. If you don't know a ton about this, that's okay. You may use this in a game you develop with Dart or Flutter later on, and you might look up and say, oh, I have to know sine, cosine, and tangent. I'll just look these up, maybe watch a video on them, and I'll figure those out. Okay, so we'll do these 3. Now, this first one, sine of pi halves, should be 1. The second one, cosine of pi halves, should be 0, and then tangent of pi halves should be undefined. The cosine and tan values won't be entirely accurate, and I'll show you that in a moment. Okay, So first off, we do max of 2 and 3, which is 3. min of 2 and 3, which is 2, the sine of pi halves, which is 1, then the cosine of pi halves. So this is 6.12 times 10 to the negative 17. That's very close to 0, but not exactly 0. That's a loss of accuracy. And then we have this huge number. It should be undefined, but there's a little bit of a loss of accuracy when using the stuff. When using the math library, we can also get random numbers. So I could do random, and then in parentheses, dot next int, and pass in an integer, in this case 100, and this will give me a random number anywhere from 0 up to, but not including 100. So let's run this to demonstrate. Clear this out. So we get 83. Run it again, we get 80, 89. This likes 80 here for some reason. Oh, we get 0, okay. And one more time, we get 6. Okay, so we get a bunch of random numbers from that. Let's take a look at a few other interesting things we can do with the math library. So we can create immutable and mutable rectangles via the math library. So I'm going to create 2 points. I'm going to call the first point upper left, and I'm going to set that equal to const point and 0, 10. And then I'm going to create another point bottom right, set that equal to const point, and we'll do 10, 0. So this should be a 10 by 10 rectangle, which is a square. So we're going to call this square rect and set that equal to rectangle dot from points. Okay, and we'll do upper left and bottom right. I didn't spell right correctly, but luckily Pulsar corrects my spelling, or just auto-completes my misspelling, so it'll work. All right, so let's run this now, and we don't get any errors, so now that's good. We can now do some things with this rectangle. And this is an immutable rectangle, meaning I can't change it once I create it. So I'm going to do int height equals square rect dot height, and then int width equals square rect. We're accessing properties of square rect, so square rect dot width. And then we can create area and perimeter variables. So we'll say int area equals height times width. Int perimeter, that's the distance around the rectangle. Well, that's going to be 2 times the height plus 2 times the width. And we can now print this. We can print the area of the rectangle is, and we'll use string interpolation here, is area square units. And we can also print the perimeter. So we can say the perimeter of the rectangle is perimeter units. Okay, so now if we run this, we'll get the area of the rectangle is 100 square units. The perimeter of the rectangle is 40 square units, which makes sense. 10 by 10 rectangle would be 100 square units in area, and it would be 40 units around the triangle, or around the rectangle. Okay, we can also create a mutable rectangle. Okay, that means we can change it. So let's do that. So I'm going to create another rectangle. I'm going to call it my changeable rect, and we'll say mutable rectangle, and we'll give it 10, 0, 10, and 10. So this will be a mutable rectangle that starts at 10, 0 and has width and height of 10. Okay, so let's print my changeable rect dot width, and we'll also do dot height. Okay, just to test that everything is working properly. So we can see 10 and 10. But now this is a changeable rectangle, so we can change these. So I could say my changeable rect dot width, let's say that equals 20, and my changeable rect dot height, let's make this not a square, and we'll make it 30. And now we can print these, and we'll see that they are changed. We don't get any errors or anything. Okay, and we'll run them. And we get 10, 10, but then we changed them, we got 20, 30. Okay, so like immutable rectangles, we can, we could figure out the area, we could figure out the perimeter with the mutable rectangle just the same way. So that's some additional things we can do with the math library. If you did like this video, please give it a like and subscribe to the channel, and thanks for watching.